Hi, I'm John Pelletier, Product Manager for the Kaminario K2, the only scale-out flash array with enterprise-class high availability and consistent 3D performance. So in this demo, we're going to show you an OLTP script, which is going to run high IOPS, an OLAP script, which is going to be high bandwidth, and an IO meter synthetic IO application, all running at the same time, putting a lot of demands on the system, and we'll show you that our latencies are always good. And on top of that, we're going to take a hot backup at that time for a snapshot of the system and show you that there's really no interruption in service when we do that. So what you're going to see here is the mixed workload. There are some arrays that work great with high IOPS and other arrays that are designed for high bandwidth. But when you try to mix the workloads, you'll see your latencies get a much different result. With ours, you'll see that our latencies stay very consistent throughout, even with these mixed workloads. What you're looking at is the Kaminario K2's graphical user interface, which is currently showing the Performance tab. We have a throughput gauge showing in purple, an IOPS gauge in green, and a latency gauge in blue on the bottom. Today's demo involves an ESXi host shown here, which is mapped to a data volume and 3 Oracle volumes for archive, data, and redo. Switching to the volume subtab, we see that the volume sizes are 0.5 terabyte, 1.5 terabytes, and about 30 gigabytes. So we'll be using an Oracle Linux VM and a Windows 2008 VM to generate our load, with some Oracle scripts and a synthetic workload from IO meter. The database we're working with is a data warehouse with 1 terabyte of data. We'll start off with an OLTP load, which is 20 users, selecting primary keys of about 0.02% of a 300 million row table. And we'll generate 40,000 IOPS with a latency of about 300 microseconds. Now let's see how the system behaves with a synthetic workload using IO meter. We'll add a workload that's 90% read and 10% write, where the IO size is 4 kilobytes. You can see with this IO meter workload, we're hitting 100,000 IOPS with the same consistent latency of 300 microseconds. Now let's run both loads, the OLTP load and the IO meter load, at the same time. As you can see, the OLTP job finishes in the same amount of time, even while running the IO meter job simultaneously. And remarkably, the latency for both jobs has stayed consistently low and flat at 300 microseconds. Now we're going to run an OLAP workload, which is actually an ETL run. We're going to transfer 300 million rows from a staging area table to a fact table on the K2. So we'll be doing it in 3 batches of 100 million rows. So as you can see, we're doing it at about 10 seconds per batch. So 10 million rows per second of reading and writing to the K2 at a latency of just over 1 millisecond. So after we've transferred all the rows, we'll do a select count start SQL statement to see how many rows we've created, and we'll do that in about 10 seconds, or 30 million rows per second. So that's the end of the performance demonstration, and now we can take a look at how we back up the database instance. So if we switch to the Data Protect tab in the GUI, we show that we have 2 consistency groups defined. One has the archive volume, and the other has the data and redo volumes. So by taking a snapshot of the consistency groups, we can create a snapshot of the Oracle database that's consistent across the volumes. Back to the Performance tab, we will run the OLAP load and at the same time back up the Oracle instance. We are creating a snapshot of the database while we're in backup mode, and then we're going to flush the logs and create a backup of the archive volumes. As you can see, the entire effect of the backup were these two small dips in performance, which are due to a momentary quiesce of the application for consistency. So we can take an almost instant application consistent backup while running workloads of very high throughput. So let's try and use this new backup that we've created. We're going to run a script to mount the backup that we've just created to the ESXi host, and we're going to map it to the Oracle Linux VM. And while we're running this, let's go back to the Data Protect tab to look at our snapshot. We see that for the archive consistency group, we now have a new snapshot and a mountable view of it, which we call a replica. Similarly, for the data consistency group, we have a new snapshot and a replica. If we look at the hosts subtab, we see that the ESXi host is now connected to both our original volume and the replicas of the consistency groups. Now we're in the process of mounting these new replicas to the Oracle Linux VM. And while we're waiting for that to conclude, we're going back to the Performance tab and we're going to restart our synthetic workload on IOmeter. This has nothing to do with the replica, but we just want to keep the K2 under workload, and here you see that it's running at around 100,000 IOPS. So now we're going back to look in the Oracle VM, and we can see that we have a new device mounted under the Aura Data backup path. And if we dig deeper, we can see that we have all the files from our database in an application consistent state. Now we'll run a load on that replica. So we'll run another synthetic workload on the Oracle Linux VM to perform some actions on that replica using the vdbench utility. So we are currently running synthetic I/O on both the original volumes and on the replica. And now we're going to rerun the OLTP load on the original volume. This shows that we can run all kinds of loads on the K2 on both the original volumes and on the replica and give very consistent latency and fantastic performance results even while we're backing up or while we're using those backups. So that's the end of the demo today. So thanks for watching the video. And just to recap, I wanted to say that for your Oracle applications, this is an ideal solution because we can keep ultra low latencies even through your high IOPS applications, and that's going to speed up your Oracle database application. On top of that, we can take hot backups with snapshots, and that'll give you your high availability. So thanks for watching.